today's video, I'm going to discuss congruence of right triangles. Let us recall first that a right triangle is a triangle with one right angle. So this is an example of a right triangle. And in a right triangle, the opposite of this right angle here, 90 degree, is the hypotenuse. So this is the hypotenuse. And the other sides are called as the legs. So the first theorem that I'm going to discuss is the LL Congruence Theorem. So LL Congruence Theorem states that if the legs of one right triangle are congruent to the legs of another right triangle, then the triangles are congruent. So in here given is AB is congruent to DE and BC is congruent to EF. Now, since angle B and angle E here are right angles, we can say that the two angle B is congruent to angle E. This is because all right angles are congruent. Line segment AB is congruent to line segment DE and line segment BC is congruent to line segment EF. So in here, this is just an application of the SAS congruence postulate. So we can say that triangle ABC is congruent to triangle DEF. This is by the SAS congruence postulate. So if we're going to summarize the result here, if you are going to have two right triangles with the two legs that are congruent, we can say that the two triangles are congruent. So this is just an application of the SAS congruence postulate. The next one is LA Congruence Theorem. If a leg and an acute angle of one right triangle are congruent to a leg and an acute angle of another right triangle, then the triangles are congruent. So in here, the given is line segment AB is congruent to XY, line segment XY, and angle A is congruent to angle X. Now, since these two angles here, angle B and angle Y, are right angles, meaning these angles here are also congruent. So in here, we are just applying ASA congruence postulate. So we can say that triangle ABC is congruent to triangle XYZ. This is by the ASA congruence postulate. So for any two right triangles, we'll just need to prove that an acute angle and one leg are congruent so that we can say that the two right triangles are congruent. So this is what we meant by LA Congruence Theorem. Okay, the next one is HYA Congruence Theorem. If an acute angle and the hypotenuse of one right triangle are congruent to an acute angle and the hypotenuse of another right triangle, then the triangles are congruent. So given here that angle H, this is an acute angle, is congruent to angle D, and line segment HT, the hypotenuse of one right triangle, is congruent to line segment DY. Now, this is just an application of the SAA congruence postulate. It's because in here, angle O and angle A are congruent because these two angles here are right angles. So we have two pairs of corresponding angles which are congruent, angle H to D and angle O to angle A, and an excluded side angle or line segment HT congruent to line segment DY. So we can say that triangle HOT is congruent to triangle DAY using the SAA congruence postulate. Now, if we're going to summarize this one, for any two right triangles, we'll just need to prove that an acute angle, angle H and angle D, or we can have angle T and angle Y, and the hypotenuse in here is HT and line segment DY to be proven congruent so that we can say that the two right triangles are congruent. Then the last one is the Hyl Congruence Theorem. If a leg and the hypotenuse of one right triangle are congruent to a corresponding leg and the hypotenuse of another right triangle, then the triangles are congruent. So given here that GI, the hypotenuse of this triangle here, is congruent to JL, and HI is congruent to KL. If we're going to put triangle JKL below triangle GHI, we can have this figure here. So we'll just extend this one. So since HI is congruent to KL, we can say that this is also the length of KL. And this one here is the point J. And since JI is congruent to JL, you can have this line segment here congruent to this line segment. So in here we can have an isosceles right triangle. And if we're going to use the isosceles triangle theorem, it states that if two sides of a triangle are congruent, then the angles opposite those sides are also congruent. So we can say that angle G here is congruent to angle J. And by this one, we can prove that these two triangles here are congruent using the SAA congruence postulate. So we can have these two triangles GHI and JKL as congruent. So triangle GHI is congruent to triangle JKL using the SAA congruence postulate. Now let's have some exercises here. So number 1, to apply the congruence indicated, give the corresponding parts of the right triangles which must be congruent. So we have here the figure. Triangle PAN with right angle at angle A, and triangle BUS with right angle at angle U. So to apply the congruence of LL congruence theorem for number 1, we're going to have here line segment PA is congruent to the corresponding side, which is, or corresponding leg, which is line segment BU, and line segment AN congruent to line segment US. Then if we're going to have number 2, LA, so leg and an acute angle, so we can have here angle P is congruent to angle B, and line segment PA congruent to line segment BU. Or we can have another solution here. We can have this line angle here, angle N, congruent to angle S, and line segment AN congruent to line segment US. Then Hyl Congruence Theorem, let's have first the hypotenuse. So line segment PN is congruent to line segment BS. And a leg here, let's have line segment PA congruent to line segment BU. And then we can also have another pair. Let's have line segment PN congruent to line segment PS, and line segment AN congruent to line segment US. Then for HYA congruence theorem, we can have here line segment PN congruent to line segment BS, and angle P congruent to angle B. Then another one, we can have line segment PN congruent to line segment BS, and we have the other acute angle here, angle N congruent to angle S. So this will be our solution. Number 2, give the congruence required to prove that triangle ABC is congruent to triangle DEF. So number 1, given that AC is congruent to DF, so these are the hypotenuse, and line segment AB is congruent to DE. So hypotenuse and leg, so we can have the congruence as Hyl congruence theorem. Then for number 2, given that angle A is congruent to angle D, this is an acute angle, and AB is congruent to DE, so this is leg. So we can have this one as LA, leg, and an acute angle congruence theorem. Then number 3, given that AC hypotenuse is congruent to another hypotenuse DF, and angle C is congruent to angle F. So this is HYA congruence theorem. Then last one, number 4, given that BC is congruent to EF, and line segment AB leg is congruent to another leg DE. So this is congruent using the LL congruence theorem. I hope this video helped you. If you have questions about the topic, please comment down below, and see you next time.